Hi, this is lesson 6.2 in Algebra 2, and in this lesson we're going to be talking about how to multiply and divide radical expressions. Now, if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is equal to the nth root of a times b. So in other words, when you are multiplying radicals, if this number, the index, is the same, then you can just multiply the numbers together that are underneath the root, as long as the index is the same. So in this example, these are both cubed roots. So the answer would be the cubed root of negative 4 times 2, which is the cube root of a negative 8. So multiply the negative 4 times 2. And from there, you can simplify. What number cubed gives you negative 8? Well, that would be a negative 2, because negative 2 times negative 2 times negative 2 is a negative 8. Now, in this next example, this is a cubed root, this is a square root. N is not the same, so you cannot simplify any more than that. All right, here's another example. Now, in this first example here, you have a fourth root and a fifth root. Again, you cannot simplify. Let's look at the next example. So we have a fifth root and a fifth root, and they're getting multiplied. So the answer is the fifth root of negative 5 times negative 2. That's a positive 10. And that's all we can do with that problem. Here's another question. What is the simplest form of the square root of 50 x to the 7th? Now, when we are simplifying radicals, remember you cannot have any perfect square factors in a square root. So you look at your list of powers and you look and you'll see, well, 50 is not on there, but are there any perfect square factors that are on there that go into 50? Well, 25 does. So you would write that as 25 times 2, and then you have x to the 7th. So the square root of 25 is 5. And if this is the square root of x to the 7th, there are 3 groups. 2 goes into 7 3 times. And then you would have 2x here. There'd be 1x left inside. So that is your answer, the simplified form of that problem. Let's do that with a cubed root. So if you look at your list of perfect cubes, you'll find that 54 is not a perfect cube, but 27 is, and that is a factor of 54. So you want to break that down. Now the cubed root of 27 is 3. And if you look at how many groups of 3 are there, if you have 5 x's, well, there would be 1 group of 3. 3 goes into 5 one time, and there would be 2 left over. So inside you have a 2, and then you have x squared. And if that's confusing to you, remember that is the cube root of x to the 3rd x squared, because 3 plus 2 is 5, and the cube root of x cubed is an x, so that comes out front, and you'd have 2 left inside. Now let's talk about division. So if the nth root of a and the nth root of b are real numbers, and b is not equal to 0, because remember we can't have a 0 in the denominator, the nth root of a divided by the nth root of b can be written as the nth root of a over b. And you'll want to go from this form to this form if your a and b can be reduced, okay? So in this example, we look at the numerator and the denominator. The 2 and the 18 can cancel. You have x's that would cancel, so you would write it all underneath one radical, and then reduce where you can. So 2 goes into 2 once, 2 goes into 18 9 times. Now, if you have 3 x's in the denominator and 5 in the numerator, the 3 here will totally cancel, and if you cancel 3 on the top, you'll have 2 left. So in the numerator, you would have 9x squared, and everything canceled out in the denominator. The square root of 9 is 3, and the square root of x squared is x. In the next problem, let's put everything under one root because 3 goes into 162, and the y's will cancel. Some of them will. So 3 goes into 162, or 3 goes into 3 once. It goes into here, let's see, 54 times. And then y squared will cancel, and if you cancel 2 of the y's in the numerator, you'd have 3 left. So here's what we're left with. The square root of, oopsie, cubed root. I made a big mistake. That's a cubed root. The cube root of 54y to the third. But we're not done yet because we have to look at the list of perfect cubes, and we'll see that 54 can be divided by 27. So we have to write it like this. 27 times 2y to the third. Now the cube root of 27 is 3. The cube root of y cubed is y. And then you have the cube root of 2 left inside. In the next example, again, we'll look from numerator to denominator and see that, oh, things can be canceled. See, so we have 50 x to the 6th over 2x to the 4th. So the 2 will go into 2 once. 2 goes into 50 25 times. X to the 4th cancels, and if you cancel 4, you'd have 2 left. So that gives us 25 x squared in the numerator, and everything's canceled in the denominator. From there, the square root of 25 is 5, and the square root of x squared is x. Now, this is not in your notes, but this is for review. Let's say you have the square root of 3 over the square root of 5. Well, by the definition of division, that's equal to the square root of 3 over the square root of 5. And if you'll recall, we're not supposed to leave radicals in the denominator. So what we need to do is we need to do what's called rationalizing the denominator. So what we want to do is make a perfect square in the denominator. So we're going to multiply by the square root of 5 over the square root of 5. Remember, this, anything over itself is equal to 1. So we're not changing the value. So when you're multiplying fractions, you multiply straight across. So you have the square root of 15 over the square root of 25. And the square root of 15 is in the numerator, and the square root of 25 is 5. So now we don't have a root in the denominator anymore. And if you type in your calculator the square root of 15 divided by 5, and you type in your calculator the square root of 3/5, they are the same. This and this are equal to each other, but this is in the proper form. So we made a perfect square in the denominator. So in this problem, let's see what's going on here. We have a cube root of 7x and a cube root of 5y squared. Now in this problem, we have cube roots in the denominator, and nothing cancels from the top to the bottom. So we have 7x, and then we have the cube root of 5y squared. So what we want to get rid of, in order to get rid of the radicals, is to make a perfect cube. And there are a few different ways to do this. But what I would say is look at your chart with cubes and look at what number on that cubed chart does 5 go into. Well, it goes into 125 is the first number I see. So I would have to multiply 5 times 25, and that would give me 125. All right, now if I have y to the second, I want to end up with y cubed. So I'm going to have to multiply by 1 more y. And whatever I do in the denominator, I have to do in the numerator. So watch this. So in the numerator, I have the cube root then. We have 7 times 25, that's 175, and x times y. In the denominator, I have 5 times 25, which is 125, and y squared times y is y to the third. So the cube root of 125 is 5. The cube root of y cubed is y. That's my answer. And nothing will cancel from the numerator to denominator because the numbers in the top are in a cubed root sign, and these are not. And so that's your answer. Let's do one more of those. So if you look from numerator to denominator, nothing cancels. All right, so we need to have a perfect cube in the denominator. So 12, we look at what does 12 go into? Let's see. Look at your list of cubes, and I'm just dividing. 216, does it go into there? 18 cubes. So let's see, 12 goes into 216 and 18 times. So I'm going to multiply by 18 because 12 times 18 is 216, and I can take the cube root of that. And I need y to the third, but I only have y squared, so I need one more y. And I have z to the 1, so I need 2 more z's. So again here, I'm trying to find a number that 12 will divide into, but a number that's a perfect cube. So it goes into, 12 goes into 216. Now, when you multiply these together, multiply straight across, then you have the cube root of 5 times 18, I need to punch that out, is 90. And then you have x squared, y, z squared. And 12 times 18 is 216. And then I would have y to the third, z to the third. So cube root of 90 in the numerator, x squared, y, z squared. In the denominator, I have the cube root of 216. Whoops, let's just go ahead and simplify that. What is the cube root of 216? It is 6. And the cube root of y cubed is y. The cube root of z cubed is z. So there is my answer for that one. All right, so go ahead and take a look at your homework and let me know if you have questions. Thanks for watching.